Hi, this is Doc, and I'm ready to do a short lesson, but a fun one, and one you can eat, which is always fun. Um, it's going to be for my chemistry class as well as my middle school science class. And what you'll need for the experiment that I'll do at the end after I talk a little bit is um, some candy. I like dots. This happens to be the Easter type. It has like 5 different flavors, which is good. So you need some candy. You'll need some toothpicks. Okay. You'll need a bowl or some type of a little Tupperware container or something to put the candy in, so you can sort the candy. And that should be enough to fabricate or build molecules. Now, if you remember, we were talking about atoms, and I had you draw a picture of an atom with the proton and the neutron in the center with the electron floating around. That was the atom, which I said was kind of the building blocks of everything of matter. And each atom is different, though. It has a different number of protons and neutrons and electrons, and the way scientists have ordered them is on, if you remember, on the periodic table called periodic table of elements. And I'll refresh your memory a little bit. Remember, it's this chart that you see all the time. You see it up in my classroom, okay? And that's the periodic table. And some of you did the element superhero project in my class. Some of you haven't. But what basically they've done with the periodic table is taken every different type of element and put it on a table so we can kind of group them by their behavior. And by their behavior, I mean whether they're charged positively or negatively or don't have a charge, whether they interact or they don't react very much with other elements to form molecules. And that's what we're going to do today, is we're going to make some molecules. Now, first, I need to empty out my candy into my bowl, which I've done right here. And I have 5 different colors. As long as you have 3 colors, maybe 4, you can use gumdrops, dots, jelly beans. Heck, you can use fruit if you want. There's a lot of things you can make molecules with. Probably the most key ingredient is the toothpicks. So you want to get some of your toothpicks out and ready. And then you want to sort your whatever candy you're using or food they're using by elements. So what I've done is I've taken all the blue ones out and I made that oxygen. So I'm going to show that up here. So my blue gumdrops, my blue dots will be oxygen. Okay. Next up, one of the most common elements is hydrogen. So my hydrogen is going to be a red dot. Okay, red dot. Or gumdrop or whatever candy you have. Another common thing that we're all made up of is carbon. Carbon is going to be my yellow dot. So you can see there's my yellow dots. And again, you can use fruit or whatever you want. What I'm doing is when I'm using those, because that's going to be my major building blocks of some of the common things that you will know of, and I'll build a molecule for you so you can take a look, is that you need to take the 2 elements and combine them, put them together. And for example, if you had sodium and chlorine, you'd have sodium chloride or salt, table salt, and it would look something like this. If I were to build it, okay, assuming that I labeled, the sodium was green and the chlorine was orange, that's what I would do. And that's what we're going to build today, okay? So the first one I'm going to do is water. Everybody knows, or I think most people know, that water is called H2O. Well, why do we call it H2O? Well, there's an oxygen molecule combined with hydrogen. Okay, most people know that. But you have to combine it in a certain order. You have to combine it in a chemical formula, and we call that H2O. H2O. Well, what does that mean? Well, that means there's 2 hydrogens for every 1 oxygen molecule. Okay, so there we have it right there. To make that water molecule, we have 2 hydrogens and 1 oxygen. Okay, what does that look like when we put that together? Well, if you remember, I made my oxygen, which is the air, right? We have oxygen in the air, among other things. I made it blue, and then I made hydrogen, which we have in the air. Oh, ice cream man. I think I hear the ice cream man. I'll be back in just a second so I can go get some ice cream. No, I don't think I'm going to make it. Oh, well. Just one of the lovely interruptions that I have throughout the day, trying to film some of my videos. So there's the ice cream man. Comes by about every day, but at all different times of the day. So my oxygen was blue oxygen. Hydrogen, I just picked red. So if I put 2 oxygens, and 4 hydrogens together, that would be a water molecule. But I don't need that many. I just need 1 oxygen and 2 hydrogens, H2O, and it will look something like this. You can see that right there. So I took my toothpicks, here's my oxygen molecule, the blue one, and I stuck 2 toothpicks in it and stuck on the hydrogen. So that's H2O right there. Okay? Pretty simple to do, right? H2O. That's what it would look like if we were able to dive way down deep into the molecular level. Now, another one that I did was CO2. Now, what is CO2? Carbon dioxide. That's what we breathe out and what the plants breathe in, so it's super important. And its chemical formula is C, which is the carbon, which I made yellow, you'll recall. C, oxygen, which is blue. But you need 2 of those, okay? So that's carbon dioxide. Di meaning 2, so carbon dioxide. What does that mean? Well, we have 1 carbon. And how many oxygen? 2 oxygen. So carbon dioxide is 1, I think you can see, I think you can see it there. 1 carbon and 2 oxygen molecules. So now the thing is that oxygen combines with other molecules. It needs to combine with 2 things. It needs 2 toothpicks in it. Carbon, on the other hand, needs to have 4 toothpicks in it because it can accept 4 electrons. How do we know all these? Well, in the periodic table, it tells us what each element is and which family they belong into and what the charge is. For instance, hydrogen is H+. So everything below it, lithium and sodium, also have a plus charge. Where oxygen is, it's in the -2 charge column. So everything below it is -2. Okay, so that's how we figure that out. And we're not going to delve too deep into that. We'll get more into that when we deal with elements. And if you're on Khan Academy, you're probably working on that. But it's not so critical right at this point that we have you memorize the periodic table, although that is going to be one of the lessons in the future is I'm going to have you try to run off a copy of the periodic table and then fill it in. Okay, but so if we do carbon dioxide, we have 1 carbon, which is right here, my yellow, and my 2 oxygens, 1, 2 oxygens. Now notice there's 2 toothpicks going each way. So it's a double bond. It's a special type of bond because oxygen needs to have 2 toothpicks and carbon needs to have how many? 1, 2, 3, 4 toothpicks, okay? So if I were to compare them, There's water, oxygen, which needs 2 toothpicks. Hydrogens only need 1. And then here is the carbon dioxide molecule. All right. Now sometimes we use, when we get a cut or a burn, we use hydrogen peroxide. It's another type of molecule. And its chemical formula is H2O2. So it's not H2O, it's H2O2. All right. So it's a little different the way the bondings work. I'm not going to get into too much detail, but that's H2O2, 2 O's and 2 H's. And if I put those together, it would look something like this. Notice it's kind of a weird shape because it has a double bond in there. But it's 2 oxygen and 2 hydrogen, H2O2. Okay, so that's just another type of molecule. You can Google the different type of everyday thing we use, and salt and sugar and all kind of items, and just Google molecular formula or molecule of salt or sugar or whatever you want to think of, and then you can build it by assigning a certain color to the element and going from there. Now, I built a crazy one here, and this is going to be your assignment to see if you can figure out what this crazy one is. I got to hold it back here a little bit. There, see that? All those. That makes a very common thing we use almost every day, or we'd like to use every day if we could. Some of us can't, but most of us do use this in some form or another because that's how we get energy. And I'm going to give you a clue. The molecular formula for this is C6H12O6. C6H12O6. What the heck is this big conglomerate, this big molecule? So C6H12O6 is the clue. And so if you can try to figure that out, and just write it down on a piece of paper, whatever you think it is, and you can show it to me in the Zoom office hours, you'll get credit for this assignment for today. So again, C6H12O6, I'm not going to write it down. I want you to pay attention. Hopefully you got that, because that's the clue. It'll be easy. You can Google that and you'll be able to see what that was. Okay. Hopefully you're doing well in Khan Academy. It's been great seeing you guys in the Zoom chat rooms and in the my office hours. And if you have any questions, please don't hesitate to let me know about that. Okay, so that's my gumdrop or dots building molecule video. Okay, take care. Doc out.